worked for BASE. Back then it was called Department of Energy and Climate Change. And now I work for low carbon contracts company. That's an organization that manages the CFDs, the contracts for differences, that renewable generators are using to de-risk their projects. So, all our offshore wind, not all, but some of our offshore wind farms, onshore wind farms, anaerobic digestion units, and some other renewable projects, including Hinkley Point, managed by LCCC. So my background is in geology and also environmental management, and I also have a degree in business administration, so a mixture of things. And yes, we've got the slides already here. Excellent. Yeah. Thank you very much, Iris. So I'd like to make a short presentation about the company called Deep Branch, who came up with this innovative product that turns CO2 into a feedstock that could be used both by fish and the chickens. And it's a very exciting technology, I think. I thought, well, I'd love to learn more about what they do and share it with you. So the next slide, please. Thank you. So what they are, that's a small company that was founded a few years ago, and they've been very, very successful in securing funds from various sources, from the UK government, from Horizon 2020, from Barclays, and also from Total, and other private investors. So they work also with a number of stakeholders, such as obviously the Drax Power Station, because they use the CO2 produced by Drax Power Station and turn it into a product called a single cell protein through a fermentation process. So Drax is one of their stakeholders, but also Sainsbury's and some other artificial intelligence companies. And I don't remember what they're called exactly, but Heidi, I believe, right? A lady from Cambridge quantum mechanics company. So I think that's one of those, great examples which could be used to show how the advanced artificial intelligence innovations could be used for our bio products and biomaterials. What else about them? Yes, also if you could move to the next slide. So yes, this is a scheme that shows you the sort of the process, the high level summary. So they take CO2, you can see on the left top corner from the Drax Power Station. And so it's a CO2 and also hydrogen are then used as the energy source for turning them into the protein. So the next block you could see, it's the fermentation tank. And then the output of that is a single cell, they call it single cell proton product, which is then used for as a fish stock and also for poultry processes. And then at the moment it's in the pilot stage, and then they're planning to scale it up as they're going through the testing and at the moment at the Drax Power Station. So why it's important to have this technology sort of developed on a commercial level? Because I think it's great, it's offering great it's a great CO2 savings, obviously, when you think about the fish stock that at the moment is being brought, let's say, to Scotland all the way from South America. That's generating lots of CO2, plus the other source of protein for fish, salmon, is the soy, and they require lots of land. So, deforestation and water consumption adds a lot of pressure on the nature. So by having it sort of produced on a more localized scale will have to help us to reduce our CO2 footprint. And of course, a big question, the big problem with the CO2 emissions. So it's kind of a win-win, capturing CO2, to turn it into fish stock. What sounds like a great plan to me. The next, and the cost, obviously, and they're still working on it to make it competitive with the other sources of fish stock at the moment. So the next slide. So this is basically the summary of the core processes. You can see, and on the left is a picture of this fermentation unit, which is currently installed at the Drax power station. So the CO2 is transformed into the proton via product through gas fermentation process. Then they develop the proton-based feed, and they have a sustainable animal products at the end. So that's really it. If you have any questions, I try to do my best to answer them.
That's fabulous. I don't